Hello, welcome to this new assignment. Today we're going to explain the intermittent aerobic power tests and a comparative analysis. We're going to compare the 3015 IFT, the Gacon test, and the list. Why does this test matter in team sports? Because these team sports require repeated high intensity accelerations, decelerations, and change of direction. We must assess not just the aerobic engine, but the ability to repeatedly start and stop the gearbox and the brakes. The test mimic physiological stress of soccer, rugby, handball better than a continuous running. Results directly inform interval training velocities and conditioning zones for specific positions, and this connects the laboratory metrics to actionable field performance monitoring and fatigue management. This is the car system framework. The engine would be the capacity to produce energy oxidatively, high engine, high continuous speed. The gearbox is the cost of changing speed repeatedly, requires neuromuscular power and efficiency. And the brakes is the change of direction and eccentric control. It's mechanical load of stopping, turning. This is crucial for recovery between bursts. 3015 IFT, engine, gearbox, and brakes. It's a complete system. Gacon test, it's engine only, aerobic power. And the list would be engine plus brakes. This is game endurance. So on a 1315 intermittent fitness test, what would be the protocol and structure? You have a 40-meter shuttle run, 20-meter out and back, performing specific zones, requires changing of direction of 180 degrees. The interval structure will be 30 seconds work, 15 seconds rest, high intensity running interspersed with short passive recovery walking. Starts at 8 km per hour, increased by 0.5 km per hour. Every stage is a total of 45 seconds on the cycle duration. What is the termination and the output? Stop when unable to reach that 3-meter zone 3 times consecutively. The score is the final speed. It's velocity intermittent fitness test. What it measures? Intermittent aerobic power, incorporating change of direction ability, recovery, and anaerobic capacity. This would be the 40-meter line, but you'll go 20 meters out and back. So you run 20 meters out, turn, and run 20 meters back. That's supposed to be in 30 seconds. You have 15 seconds to walk. The car system components, as we said, engine, gearbox plus brakes. The physiological demands, you have a dominant aerobic base. This is the primary energy source, is the oxidative. This test elicit maximal heart rate and near maximal oxygen uptake. PCR resynthesis, the 15 seconds walk recovery challenges the rate of phosphocreatine replenishment. This is a key marker of intermittent fitness. The glycolytic burst, high intensity stages require significant anaerobic contribution. Lactate accumulation occurs but is managed via recovery intervals. Neuromuscular cost, repeated change of direction adds mechanical load. 180 turn requires eccentric braking and explosive reacceleration. 90 to 100% of VO2 max elicited, high anaerobic capacity, fast O2 kinetics, and mixed engine, gearbox, and load. The fatigue patterns in these stats, you have a peripheral fatigue, the eccentric braking, high mechanical load from 180 turns, cause local muscle damage risk, ion accumulation, hydrogen and potassium build impairs muscle contractility during sprints. The neuromuscular, the turning efficiency, loss of coordination in change of direction phases as fatigue sets in, and the power output declining ability to decelerate after each turn. The metabolic stress is the PCR depletion in complete resynthesis during the short 15 seconds recovery periods across the stages, and the lactate accumulation moderate to high levels due to repeat glycolytic burst. You also have central factors like the neural drive challenge near exhaustion. The high RPE is a key termination factor. A pacing strategy, mental fatigue affects ability to maintain a required pace. The practical application, you have a precision prescription. You use the BIFT to prescribe individualized hit intervals, more accurate than velocity VO2 max for shuttle-based running. The sessions inherently train the gearbox and brakes, and the position specificity, tailor volume based on game demands, wingers, midfielders, high volume versus defenders, forwards, high intensity. You have here the training zones, 85 to 90, extensive intervals, longer durations, 3 to 4 minutes. This is aerobic maintenance, large field games, 95 to 100%. Medium duration, 1 to 2 minutes. VO2 max development, 15 seconds, 15 seconds runs. And you have 105 to 110, short burst, less than 30 seconds. This is for anaerobic power, repeater sprints. This is sports specifics, like for soccer. For rugby, you use conditioning of fit groups. And for field hockey is for critical high turnover demands. Progression model, phase 1, increase volume and total reps. Phase 2, increase intensity. Phase 3, decrease density. You cut the rest. The Gacon test is 45-15. Is the protocol and structure. The track fills it up, typically performed in a 400-meter track and field with cones every 6.25 meters, continuous running path, 45 seconds work, 15 seconds rest, longer work bouts compared to the 13-15 IFTs, stressing sustained output. The speed progression starts at 10 km per hour, increased by 0.05 every stage. 1 minute is the total cycle duration. The termination and the output. You stop when unable to reach the target cone. Score is the final speed. Velocity V Gacon is velocity Gacon. What it measures, maximal aerobic speed on field, focuses on the aerobic engine capacity. The aerobic power and central fatigue is an aerobic dominance. Primary energy system is oxidative. Sustained 45-second efforts elicit a high percentage of VO2 max, similar to continuous running test. Fatigue is predominantly central, cardiovascular, neural, rather than peripheral, as there's minimal eccentric braking load. Longer work bouts, 35 versus 30, cause greater lactate accumulation than 30-15 IFT, pushing anaerobic threshold limits. Pure engine measure evaluates the engine in isolation. No gearbox, no brakes, or components influence the final score. Lactate accumulation is high. Minimal neuromuscular load is an engine system focus, and it's a 45 seconds work duration. Practical applications. You target the engine directly without mechanical stress, ideal for building pure aerobic capacity. You prioritize for sports with continuous flow, like basketball and handball, focusing on sustained output. You use when avoiding change of direction is critical, like return from a lower limb injury while maintaining conditioning. Here are training zones, 80 to 90, long intervals, 6 to 8 minutes, basic endurance, low mechanical work, 90 to 100, tempo, this is aerobic, medium intervals, 4 to 6, threshold, development sustained power, and 100 to 105% max aerobic power, short intervals like 2-3 minutes, VO2 max peaking, high intensity. Sports specificity: basketball, court based aerobic power runs, handball, continuous back and forth flow, rehab, early stage engine restoration. The combination strategy: pairing, add separate, change of direction drills, focus, isolate engine versus gearbox, and timing, best for GPP or heavy weeks. The Landborough Intermittent Shuttle Test, or LIST, is cyclical pattern: walking, jogging, cruising, running, and maximal sprinting. Perform over 20-meter shuttles, includes frequent 180-degree turns, high braking and eccentric load. Duration and simulation: designed to last around 90 minutes, two times 45-minute halves, simulating actual match play demands. Fixed sprint components: embed 15 meters maximal sprint every cycle to monitor fatigue power decrement. What it measures: game specificity, endurance capacity, and the ability to maintain high intensity efforts under fatigue. The physiological demands is high ecological validity, closely mimics match demands with mixed metabolic profile, integrating walk, jog, cruise, and sprint phases. The glycogen depletion: prolonged 90-minute duration causes significant muscle glycogen depletion, reflecting through game endurance limits. You have also the eccentric braking. This is substantial deceleration exposure, creates significant mechanical load and muscle damage risk over duration. Cardio and thermal strain: evident cardiovascular drift and thermoregulatory stress occurs as the test progresses, impacting performance and capacity. The metabolic profile is mixed. The eccentric load is high. The duration impact is around 90 minutes, and specific capacity on game. It's a game specific capacity, basically. The fatigue patterns: you have a substrate depletion. The glycogen depletion, significant reduction over 90 minutes, limits high intensity output and determined load. Core temperature rise contributes to cardiovascular drift. The performance decrement: sprint times progressively slowing from 15 meters, slowing of 15 meters, 20-minute sprints across blocks. Marker of fatigue: drop off in sprint speeds, serve as fatigue indicator. The eccentric cost: breaks, braking fatigue, accumulating eccentric loads degrades deceleration ability, change of direction quality, visible decline in turning sharpness and efficiency. Cumulative failure: on the central fatigue builds, over duration rather than acute point. Perceived exertion: the RPE rises steadily despite standardized sub-max speeds. Practical application: match simulation replicates physiological demands of soccer, engine plus brakes, better than continuous runs. Return to play: test the player's robustness to braking, change of direction under a cumulative fatigue before full completion. Frequency limit: due to high eccentric load and duration, 90 minutes, do not test frequently, max 2-3 times per season. The primary application: soccer simulation, valid for 90-minute simulation, replicates the game demands. Position agnostic. Robustness: checks braking integrity, assess mechanical fatigue, late stage rehab. Works as a diagnostic, use the select blocks. Shorter field diagnostic: you have a weekly check-in also. The monitoring metrics: the internal load, the heart rate drift, the RPE per block, sprint decrement, speed loss over time, quality, visual breakdown of change of direction technique. Key constraints: it's time heavy, takes full training session, fatigue needs 48 recovery post test, setup, complex audio and track setup, head to head comparison. You have the structure, we already saw the structure between all of those. You have a 30 on a 30 15, 30 seconds work, 15 seconds rest, Gacon 40 seconds work, 15 seconds rest, list multi-speed cycles, the progression 0.05 per stage until exhaustion, 0.05 km per stage until exhaustion, fixed intensity blocks, 90-minute duration, physio stress 30-15, it's mixed, anaerobic, high change of direction demand, Gacon pure aerobic power, sustained effort, list, mix prolonged glycogen depletion, the fatigue type, PCR depletion plus neuromuscular, Gacon test is central cardiovascular plus lactate accumulation, and list cumulative plus eccentric braking fatigue. Specificity is high. Intermittent sports like soccer, rugby, and handball. Gacon is moderate, just aerobic base, low COD specificity, and list very high ecological exact match simulation. The car system, we said engine, gearbox, brakes, engine only, and engine and brakes. Which test? When? This is coach decision tree framework. What's your primary goal? You start here on the goal assessment. Specific need specificity or rehab, return to play robustness, list blocks, check braking quality under fatigue, 30-50 IAFT, full intermittent capacity, engine plus gearbox. You need an assessment focus, need aerobic capacity, Gacon test, pure aerobic engine, simplicity plus maximal acceleration speed, and the list game simulation, endurance plus brakes. The key takeaways for coaches: practical implementation and decision making, match test to questions, choose based on what you need to know, aerobic engine, game endurance, or intermittent power. Set accurate zones, use the percentage of BIFT and percentage of velocity Gacon to prescribe precise intensity for extensive aerobic versus intensive anaerobic intervals. Balance engine versus brakes. Ensure programming addresses both the metabolic engine capacity, the neuromuscular cost of braking and change of direction. Progress in loading, integrate change of direction and eccentric braking load to build tissue tolerance before high volume testing. Don't just test, monitor heart rate response, RPE, mechanical drop-offs during sessions to adjust loads dynamically. Here are the references that I used for this presentation. Thank you very much.